Electronics can only be in two states, on or off. So how can they do maths? Well, they don't count with the decimal system, but with the binary system. In the decimal system, there are 10 numbers, hence the dash. Once we run out of numbers, we place a number in front and turn the original number into a 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Since computers can only be on or off, they can only have two numbers, hence the bi. The numbers are 0 and 1, so you're thinking 0 equals 0, 1 equals 1, 10 equals 2, 11 equals 3, 100 equals 4, etc. And while that is right, it's not the correct way to think about it. Have a look at this chart. At the top here, we have the powers of 2, which are 1, 2, 4, 8, 16, 32, 64, etc. But then reverse. Now, let's say we have a binary number like 0, 1, 0, 1. Then what we do is that we input it into here. And, well, what this is saying is that 1 is activated and 4 is activated. And you plus the activated ones together. So 0, 1, 0, 1 equals 5. Pretty easy. Something to note is that if you have a bigger number, let's say, like, you have more digits, you just keep on doing the powers of 2s and, like, so on and so on. That's how computers do math, but binary can get really long, so how can we shorten it? The answer? Hexadecimal. Hexadecimal consists of two parts, hex, which means 6, and decimal, which is the 10-digit counting system. Hexadecimal means the decimal system plus 6, meaning as 16 digits. These digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and instead of 10, we go to A, B, C, D, E, F. When we run out of numbers, we do what we do in the decimal system, so 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 1A, etc. For example, 10 in the decimal system doesn't equal 10 in the hexadecimal system. It equals 17. Instead, A equals 10. Binary to hexadecimal conversion does have a specific method, but converting binary to decimal to hexadecimal is simpler. How do we write text though? Well, with systems like ASCII. Well, ASCII isn't the only one, it's the most common. Anyway, ASCII assigns characters to numbers. For a fictitious example, let's say A equals 18. Then in binary that'll be 0001, 0010, and in hexadecimal that'll be 11. That's for text, but what about images and stuff? We'll talk about that in part 2.